Welcome back to our stove upgrade series. This time I'm installing secondary burners. Once again, I'm going to subject you to some of my fine artistic skills. Looking at the side view of the stove, when starting the stove, fresh air comes in through the bimetal thermostat damper. The air comes up through the ash grate and stokes the fire and coals. The gas and smoke mix with some fresh air in the new burners, but since it's not hot enough, it doesn't yet combust. There's also a new ceiling above the burners to force the air forward and up into the secondary chamber, then venting through the stack. This chamber will be used in the last phase of this project. As more fuel starts to burn and the burn chamber gets hotter, the wood gases start to combust, and as the stove continues to heat up, the damper door automatically closes, choking most of the fresh air intake from the bottom and slowing down the burn rate of the wood. There is still a small amount of air that comes in through here to help stoke the coals through the grate. Since there is a strong draw pulling up the chimney, this causes more fresh air to get sucked into the stove through the secondary burners and igniting a large portion of the wood gases. There's enough added air where the flames are getting drawn up into the upper chamber, creating a rockety effect. From a top view, the fresh air is drawn through the side of the stove where it travels through the central tube. The goal was to preheat the air before it combines with the wood gas. With it only traveling roughly 25 inches through 1/8 inch steel, I doubt the temperature has a significant increase. The air then travels down 2 burner tubes, injecting air into the firebox, causing the wood gas to ignite. The central tube is made from 1.5 inch steel box tubing. The steel should last for a couple of years and is really just for experimenting. When it wears out, it will need to be replaced with stainless. The burn tubes are 1 inch box tubing, so the inside profile of the 1.5 inch tubing is slightly greater than 2 of the 1 inch tubes, so it won't restrict the airflow. The holes are drilled along the side of each tube every 1/2 inch. When drilling, it was easy enough to go all the way through, so it basically drills 2 holes with 1 pass. After drilling the first tube and seeing how misaligned the holes were, I wised up and clamped a backstop to the drill press. It makes it look much better even though no one will ever see the inside of the stove. With surgical precision, I needed to cut some holes in the sides of the tubing so the air could flow properly. My 4-inch cutoff wheel is precise enough for the job, and to get into the tight corners, I wore through a dozen cutoff blades with my knockoff Dremel tool. Now that all the pieces are cut, the tubes are laid out, aligned and tack welded together. Once I knew it was set up properly, all the seams were welded. I must admit that having a MIG welder is one of my best investments I've made for my tool collection. A few pieces of scraps are welded over some of the ends and cut down to the proper size. One last addition is to weld a flange near the opening, so there's a way to mount the burner to the stove. Here's the finished burner showing the mounting flange. The 2 burner tubes with holes coming through horizontally and a small leg to help add support at the rear of the stove. The burners mount through the side of the stove, so a few more modifications to the stove are needed. These holes are slightly larger than the burner, so there's a bit of slop left for adjustments. Two holes are drilled through, which are used to mount the burner to the stove. Mounting each burner is fairly easy and they fit right into place. It's always nice to see these fit together the first time, especially when it's difficult to patch misplaced holes. I use stainless bolts to minimize corrosion so it's easier to dismantle. I debated putting a gasket between the burner flange and the stove wall, but it doesn't appear to be leaking through this area. Here they are mounted into place. You'll see that one has already been tested prior to this filming, just to make sure it was going to work properly. The last step was to add a ceiling above the burners to help keep the gases near the burner and to create a section above it for the next phase of the project. The stove came with this bimetal thermostat that's linked to the damper. As the stove heats up, the damper will close, choking some of the burn. Keep in mind that the secondary burners continue to burn, so the stove will continue to produce a lot of heat until there is no fuel remaining. While it's burning, it's impressive to see the secondary burners suck air in. Here's a good example of the burners in action. You can't see the wood, but there's a couple of small flames coming up from them, a few flames around the glass, mainly because there is some air leaking around it. It's tricky to see, but right at the top center you can see the flames looping back up into the upper chamber. The stove usually stays around 500 degrees. Without the burners, I've seen the temperature vary all over the place, sometimes hitting 700. It's not rocket mass heater temps, but the cooler burning should help the stove from wearing out. That's about it for now. I have one more addition planned for this stove, so please like this video and subscribe to get future updates. Thanks for watching.